For those just joining, good morning, good afternoon, good evening, wherever you are in the world. Welcome to today's webinar. We're just waiting about 1 minute while we wait for everyone to filter in. And again, for those just joining, we are just waiting for everyone to get here into the room. It always takes a minute for all the folks to get filtered in. Should be ready to go here shortly. All right, looks like we have all the folks here joined in, so we're going to go ahead and get started with today's webinar. Today, we're going to be talking about security automation, leveraging Nautobot firewall models and Palo Alto Panorama for firewall as code. Covering our agenda for the day, we'll have some intros here that we're doing now, moving into the current state of firewall management, then talking about treating firewalls as code. And with that, a concept really following on to introduction to source of truth, and then treating firewalls as code with Nautobot as your source of truth, right? So that combination. And then, of course, at the end, having the Q&A. Of course, as always, feel free to put questions up in either the chat or the question area, and we will try to address them during the webinar. And then any of particular interest, we will save to the end for conversation if we have time at the end. For those of you that don't know me, my name is Tim Schreyack. I'm the Director of Sales Engineering here at Network to Code. And then with me today, I have Jeremy White and Calvin Remsburg. Jeremy?
Hey everyone, my name is Jeremy. I'm the Principal Developer Advocate. You may be catching me on blog posts or YouTube series on Nautobot development and other cool, fun things from that perspective. Done a lot with Nautobot and a lot of cool open source automation in my years. Calvin?
Hello, everyone. My name is Calvin. I am with Palo Alto Networks. I work in the consulting engineering organization, focusing mostly on helping customers understand how to take advantage of some of the automation capabilities that are inherent within our platforms.
Thanks, Jeremy and Calvin. Moving on here, just a quick promo here coming from Network to Code. If you've seen some of our other webinars, you know we always have some discount codes available for you. Today is really cool. We've got two, actually. One for our Nautobot workshops, so the Nautobot extensibility workshop and the automating Nautobot with Python and Ansible workshop. We've got a 10% discount code available for you there. And then we have one for our network programming and automation course. This is our flagship course, and we are offering a 15% off discount, which is really amazing. Definitely take advantage of those discounts and sign up. And with that, we're going to move into the current state of firewall management. I'm going to hand off to Calvin for this conversation.
All right. Thank you, everybody. Let's see here. All right. Well, again, welcome, everybody. My name is Calvin, and today we're going to talk about really quickly some of the high-level current state of how to manage security configuration on firewall processes. And then we'll show you some successful architectures on how customers are consuming automation with tools like Nautobot in their environment. We have two distinct architectures. Both of them are completely valid. But for right now, let's just kind of level set and understand kind of how we got to this point where we are. So we see across the industry, our customers are looking to automate, and there's a couple of really obvious reasons for that. Speed is one of the things that you've heard within the last 10 years as one of the primary value propositions that automation brings. Helps us achieve more with less, right? So there's an obvious benefit into there, but there's less talked about points around the operational benefits of working within an automation framework. This is to address some of the complexities when working with multiple platforms, multiple environments, multiple vendors, multiple tools. There's a lot of different things that are required in order to achieve the configuration tasks from a manual perspective. And there's just better ways of doing this within automation. And the second is we need to make sure, at least on the security side of things, that any configuration that we put forth is going to be consistent with our business objectives, the objectives that we're trying to accomplish within our security framework. We need to make sure that the policies are legit and they're ordered correctly. So we need to protect our infrastructure and deliver on these three things right here. Now, talking about, just for a second, the current change workflow, and this is a generalization, but hopefully some of this will make sense with you. Today, if we need to make a change within our security configuration, the first thing that we need to do is we need to identify what those changes are, right? So we look at a brownfield device that's online and in production, and we determine, hey, there are some things on this configuration that need to change. Maybe we're spinning up a new cloud environment, and we need to make sure that the appropriate DMZs are there, the appropriate tags or address objects are there. Something has changed in the environment that requires some kind of change, and we need to document those changes. Once we've got all those changes kind of bundled up in a nice little deliverable, what we do at that point is we turn this over to some kind of approval committee, and they determine, what's the risk of your change? Have you considered this? What are the outcomes that you're trying to deliver here? And they give the yay or the nay as to whether or not that change is actually going to go into production. Then we actually get to the execution change. Now, if it's not like a break fix situation, this typically happens under some kind of change control window. But this is the stage where we actually take the changes that we had planned and put them into production. And finally, we need to validate and document the changes that have taken place within the environment. Now, looking back at this, there's not really a whole lot of kinks within this workflow. It's logical. It gives us time to prepare. It gives it time for our teams to approve. And usually change control windows have enough time for us to execute the change. So it's not necessarily the workflow that is problematic. Rather, it's the tools that we have been using over the last few decades to actually accomplish this goal. So the most common tools that we see customers use when they're going into some kind of network change is that they've opened up Notepad or they've got like an Excel spreadsheet, and that's where all their change documentation goes within. Now, a big problem with that is, let's see if you mean to be, can you confirm that I'm not sharing the slides?
You are not sharing at this moment.
Thank you. That's the confirmation I was looking for. Please stand by. Let's try this again here. How do we see it now? Are we good? All right. So, okay, hopefully audibly you were able to determine kind of where I was going with this, right? We need to document our change. We need to go into an approval process. We need to execute, and then we need to document and validate. The workflow is legit. It's the tools that tend to be a little bit problematic on this side. Again, first of all the changes that come in are usually driven through some kind of notepad editor, text editor, and there's a lack of information, some really key features that we need out of these tools that aren't there today. One of which is some kind of historical representation of the configuration. Why were these changes made in the first place? Also, the configuration itself doesn't always tell the full story on a device. Sometimes it's beneficial to have some additional context as to what the configuration is actually representing. What are some things going on at the site? What's the rack elevation look like? What cable is connected to this platform, et cetera? Those bits of information can absolutely determine the success or failure of some of our configuration changes, and they're just not available in some of the tools that we've done today. Now, there's not a whole lot of kinks in the armor as far as approval processes go. There are some tools like ServiceNow that do have a little bit of collaboration, meaning that when I go to submit my approval, I can have someone tell me that the configuration is invalid or is not met to the certain standards that they're looking for. So there is a little bit of collaboration there. But there's no real error checking, right? There's no capability of saying this is invalid and this will break the configuration, except for whoever is approving these changes, doing that audit manually. Now, when we get to the execution, this is a very problematic stage for us because, first of all, it's not automated, right? So we're having to log in either through the command line interface or going through a graphical user interface to actually make those changes. And guess what? Both of those, the vendor CLI and the GUI, are proprietary technologies, right? So you have to be proficient in either or. And again, it's not friendly for auditing, and it doesn't provide enough error checking. There are some platforms out there like PanOS and Panorama that have built-in error checking upon configuration to make sure that it's a valid configuration. But for the most part, that's not ubiquitous across the industry. And finally, for documentation and validation, again, it's not an auditing process. I've seen some magical things happen with an Excel spreadsheet formula, but I've not seen it able to query network devices. So the process is still laborious. It's a manual process. Doesn't include any kind of context, typically, unless you hard code it in there. And it's just not error checking or friendly to operate. So this is kind of the lay of the land of where we are today. And what we want to showcase to you again is two different architectures of how to address this in a better format. So one, let's talk about how to use this within the configuration context. What are some of the tools that we deliver, or sorry, some of the tools that are available out there to help us deliver on these goals? And the first thing is our documentation or our changes are actually going to be edited inside of another text editor. This time, something that's backed up with version control. So in our case, we're going to be using Microsoft Visual Studio Code, and we're going to be opening up a repository that is backed up by a GitHub repository. This gives us additional context as far as what's the current lay of the land outside of the configuration. It provides error checking within the text editor to let you know if something is invalid or broken. But more importantly than anything, it really gives us a history. It gives us the ability to look back and say, who made what changes and what was the outcome of those changes? Extremely powerful for us. Now, we're also going to be incorporating GitHub within this approval process. Now, there's nothing really wrong with the ServiceNow delivery or BMC or any other kind of approval process, but it should be noted that when you have your project managed as code in something like GitHub, there is an approval process that you can have other teammates sign off on it, add comments, again, really driving home collaboration across your team. Now for the execution phase, in our case today, we're going to be using Ansible. And so our execution is going to be completely automated from start to finish. It is Ansible. This should actually kind of be a green check. Ansible is absolutely vendor agnostic. Just the only thing you have to make sure is how those Ansible modules are implemented for your vendor of choice. But typically, Ansible's got really, really good coverage across the board. And finally, we're going to be using Nautobot to help us with automated documentation. Jeremy's going to touch a lot of this on his single source of truth plugin conversation. But Nautobot also brings additional parts of the documentation, right? You can see prefix allocation, you can see VLAN databases, you can see rack layouts, cable connections. So there's almost no limit as to what kind of data that can be inserted into Nautobot. So this is going to be the workflow that we're going to showcase today of how customers are successfully managing their security infrastructure as code. Now, to give a detailed play-by-play, what we're going to do today is we're going to start, that's me over on the left-hand side of that screen there. And I'm going to be opening up Visual Studio Code, specifically looking at a project that manages all of my configuration as code. We'll take a look at what that looks like closer, but for here, this is just a real quick snapshot. The idea behind Firewall as a code is that we're going to take all of our security configuration and we're going to codify it, typically in a YAML format because it's easier to ingest. And this is the configuration that will represent our entire device. And this is what we're going to be using to manipulate configuration on our devices. So I'm going to start off by creating a dedicated safe space, which is something that we call a branch in the Git world. So we're going to create a branch that's going to allow me to make any kind of modifications that I want upon my production device. And then I'm going to commit those changes back up to the GitHub repository. And then someone's going to review those changes and say, okay, I like what you've done here. We'll go ahead and sort of merge them into the production branch. Once that approval process has been taken place, then we're going to visit Ansible, and Ansible is going to be the automation engine that's going to kick off our workflow for us. The very first thing that's going to happen is that Ansible is going to reach out to Nautobot, and it's going to say, Nautobot, I would like you to synchronize all of my configuration from GitHub. And then Nautobot will expose that data to us over the API, but it will also expose additional contextual information, again, about my region, about the tenant, about prefix information, etc. There's a whole wealth of information that can be captured and documented in Nautobot, and we're going to be able to pull this out with just a single API call. Once Ansible has all that really good information, it's going to go and it's going to fully provision our firewall. It's going to do things like address objects, network configuration, security policy, advanced threat protection, all those goodies. And that's what we're going to showcase today. We're going to deploy, we're going to provision a firewall from a default configuration into a fully provisioning working configuration all through Ansible. And so it will obviously be completely repeatable. All right, so enough of the PowerPoint talk. Let's first look at my GitHub repository. This is a repository that is currently being synchronized with Nautobot. So Nautobot is able to knock on the door of GitHub and say, give me all of this configuration context within this repository. And then it automatically synchronizes or adds it to the devices inside of Nautobot. This really gives us a single point to ask for all of our configuration data. So if I look in the configuration context folder right now, I can see I've got a few folders. Let's look this up. I've got some YAML files right here that kind of represent consistent configuration across my inventory. Things like my SNMP community, DNS servers, whether or not LLDP is enabled, right? These are really consistent values that should be across my entire fleet of inventory. Then I have some values that should be inherited by all of my firewall devices. In this case, I want things like custom TCP services or security profiles that are representative of logging mechanisms, right? Something that should be ubiquitous across my firewall fleet. Then I have some specifics that are available through just my specific operating system, where I look at things like applications, maybe tags, right? Things that should be ubiquitous across the firewall inventory. And then finally, we get to device-specific information. But I want to pause just real quick because I want to make sure that we understand that Nautobot, when it pulls in configuration context, you have the opportunity of allocating variables to certain groups. This should, in theory, allow you to really scale out your inventory as you're not having to copy and paste into files all left and right. You can just go ahead and take in the variable inheritance model that they've built into here. Now, in my case, I've got 3 firewalls here, Austin, Dallas, and my headquarters, but I want to deploy a new configuration for a firewall called San Antonio. And if I look at San Antonio right now, this is my Palo Alto configuration. I can see that I've really got not a whole lot of things going on here. I've got no address groups, no application groups. I've got default tag information. I've got my interfaces are not configured, not online. I don't even have any security zones on here. So, right. So this is, or security policies for that matter. This is really a vanilla firewall installation. So how do I get this firewall to a production state? Let's start with opening up Visual Studio Code. And this, again, this is a text editor that is pulling from that GitHub repository that we just looked at. And my order of operations is going to be pretty easy. I'm just going to copy a production firewall. Let's copy headquarters, and I'm going to paste it and rename the file. For those of you that are coming over into the network automation world, this is a workflow you'll understand because copy and paste is what we live and die by. So I've made my change. I've gone ahead and created a new file that represents all of the security configuration for my new firewall, San Antonio. This is where I would start going and start making some changes within this config. I could update interfaces. I could update their security zones. I could update security policies. But in my case, I want to submit this to my GitHub for my peers to review. What I'll do is I'm going to create a new branch here by clicking on this button, and I'm going to say create a new branch. And we're going to call this the branch of San Antonio. And once that has been created, all I need to do is add this new file with a handy commit message. We're going to call this San Antonio init. All right. And we're going to commit this change to our GitHub repository. Now, it's important that if you didn't know, that right now we have not affected the actual main production version of code. Although I've submitted a request to have my changes reviewed, if I refresh my page right now, I can see that configuration context has not had a new file created for the San Antonio firewall. But if I come back to the repo homepage, I can see that a new pull request has been requested, and I can look into that. From there, I'm going to see who made the change, what changes were actually made, what was their commit message. And I can see with red being additions, green being additions, red being subtractions, I can see all the changes that have been requested of this user. Now, I'm just going to speed run this, and I'm going to say that looks good to me. I fully read and reviewed all of those changes. We'll go ahead and merge this. Now, this gives us an opportunity at this point in the process of the pipeline. We have the opportunity to incorporate automated reviews and peer checks. In this case, I'm working by myself, so I'm just going to go ahead and merge this to production here. But this would be a good opportunity to incorporate that collaboration from amongst your teammates. Now I can see that the change has been successfully pulled. Let me come over to Nautobot for a second. This is a device representation of my virtual firewall San Antonio. And if I look at the configuration context right now, I can see that it's inherited some values already just because my device is a firewall. So it checks that one as far as the role, and it belongs to the PanOS platform. So it automatically had inherited some of those defaults that we had talked about using Nautobot's variable inheritance model. But we have now submitted new changes, and let's go ahead and tell Nautobot to synchronize for those changes. I'm going to click this synchronize button right here. And what Nautobot's going to do is it's going to reach out to my GitHub repository, and it's going to look for differences. And in this case, it's going to say Dallas firewall did not change, nothing to do. Headquarters, nothing to do. Austin, nothing to do. But San Antonio, there are definitely some changes that had made here. And if I refresh my page, I can now see, yes, we have address objects. If I scroll all the way down, I'll see things like security policies, NAT policies. This is perfect. So now Nautobot has a complete picture of what my configuration should be for my firewall. So we're done with staging our changes. We've approved it by going through the Git operations of merging it. The last thing for me to do is to come over into my Ansible environment and go ahead and initiate this workflow. So I'm going to log into Ansible AWX, which is a product of Ansible automation platform. I'm going to come over to my templates here, and I have a Ansible playbook that's just waiting for us to execute it. Now, to peek into this, I just want to share that this is the playbook right here, and there is no hard-coded values within here. Everything that we're getting inside of this playbook is pulled directly from Nautobot and fed into this template. This effectively allows us to use the same Ansible playbook for my entire fleet of firewalls. And all I need to do is to tell it which firewall I would like for it to execute against. In my case, that's San Antonio Virtual Firewall 1. It'll give me some information about this project. We'll look at that just in a second, and we'll click this launch button. Now, again, coming back over to our slide, what's taking place right now, we've just logged into Ansible and we've told it to execute our playbook against our new firewall. What it's going to do, it's going to reach out to Nautobot, and it's going to say, hey, Nautobot, I want you to synchronize with GitHub, pull the latest copy of our configuration data. And then Nautobot's going to extend that or expose that data back over into Ansible, which is then going to consume it and loop over all that templated Ansible playbook and push the production code or push the production configuration to the remote device. So here we can see this part taking place. You can see that looks like I misspelled Nautobot. Sorry about that, my friends at Network to Code. We're allowing it for that point of opportunity to synchronize. And now we're going to start, let's go ahead and follow this output. We're going to start to see all the various configuration things being generated. So we're creating things like application tags, application groups, address objects, all of those goodies are going to be initiated right now. Let's come back over to our firewall. Let's give a real quick refresh. Let's look at tags. And if I just hover over this refresh page, you're going to see more and more tags come through. All right, so this is incredible because it gets us out of the behavior of having to memorize how to operate a vendor's CLI or graphical user interface. You can actually use this automation architecture to represent your entire fleet of inventory. Again, there's nothing specific to Palo Alto that's taking place here. Nautobot is completely vendor agnostic. Ansible is completely vendor agnostic. It's just about getting those pieces talking together in a way that's templated and easily replicatable. All right. Coming back over into here, we can start to see now that things like address objects are being created now that we've got our tags instantiated. So we're going to go through here, and now we can just kind of, again, hover around this refresh button, just watch the magic take place as it goes through. So all in all, this provisioning process will take about 4 to 5 minutes to fully provision, but it will do it 100% accurately. And again, it's completely replicatable across your entire fleet of devices. So this is a good time for us to stop and pause and see if there's any questions that we have within the chat.
There have been a lot of really great questions in the chat, kind of talking around the decisions around using Ansible versus Terraform and that perspective. Also, checking if there's any risk or compliance checking, like PCI or SOX compliance within this playbook itself.
Yeah. So let's start there. So with the first one around Terraform, what Terraform does better than any tool out there is it enables a declarative configuration model, meaning 100% whatever is in my Terraform configuration is exactly how that firewall should operate. There's nothing within this workflow that would prevent Terraform from having success in there. Again, looking at this from a Nautobot perspective, it's not actually responsible for the automation heavy loading. It's more about pulling data out of Nautobot or out of GitHub and exposing it into whatever automation engine is requesting it. So you could absolutely replicate this framework with something other than Ansible. It could be Terraform, it could be Python, it could be Golang, it could be Nornir. Again, it doesn't really matter in that case. There are strategic benefits to different solutions. Typically, an automation framework like Ansible or Terraform is going to provide a lot of additional value, maybe not on like the technical specs, but talking about like having a consistent workflow, or in the case of Ansible, everything is YAML, and sometimes it's easier for operators to consume. So there are some non-technical reasons to go with either solution. Maybe it's speed. 5 minutes might be too long for you, right? Ansible is well revered for not being the fastest in the world, and that's okay. But if you do live in an environment where changes are constant and they need to be taking place at a rapid speed, might be a good reason to look at either writing your own or maybe switching to something like Terraform. The second question around SOX and compliance. There's nothing inherent within my playbook that I developed here that addresses those concerns. However, there's nothing to prevent you from extending the playbook. By the way, all of this that I'm showing is open source and will be available in the links to share. So if you wanted to take this automation framework and add in additional compliance or auditing capabilities, that's absolutely something that can be showcased, but it's just not something I have within this workflow. All right, so according to Ansible, it's done. It took about 4 minutes and 33 seconds. If I look into this, I can see all the things that had been changed. Everything looks hunky-dory. Let's come back over to our firewall and just do a refresh here. I can see we've got full address objects listed. I've got my custom TCP services defined. I've got a bunch of tags defined here for all parts of my configuration. Looking into the network side of things, I have security zones. They're appropriately configured in the right type of security zone with the right matching interfaces. Speaking of interfaces, we also have interface configurations here as well. Now, there's one aspect on this that I didn't touch on. My playbook does not have a commit operation associated with it. We see customers kind of split on this, and I'd be interested in kind of gauging what your perspective is on this. Some customers fully buy into the automation. And they also fully buy into the data, the validation of the data that's feeding their automation. And because of that trust that they have formed between these two tools, Ansible and Nautobot, they feel completely comfortable incorporating a commit operation immediately on the firewall. If you're unaware, a commit operation is required in Palo Alto to take all of our stage configuration changes and moving them into production. In my case, my workflow, my experience, I always wanted a human to manually audit and review. Yes, the automation person asked for a human review process, but in my environment, it made a lot of sense for us to do something like this. But we do talk with a lot of customers that actually incorporate the commit operation into the execution as well, so that they're completely decoupled from the provisioning process. They don't have to visit the firewall. They don't need to audit or review it. All right, so it looks like my firewall is fully functional, or at least the stage configuration is fully functional. Everything has been fully provisioned. Talking about lifecycle maintenance, if I needed to make changes from this point going forward, I wouldn't be logging into the Panorama user interface or going to the CLI. All of my changes would happen through that workflow that we just showcased. This is infrastructure as a code type of workflow. Everything that we do is in code, or in my case, it's in some kind of YAML data format. And what needs to be done is adds, moves, and changes take place within that YAML code, get pushed up to GitHub for a review process, and then ultimately pushed out into production. So understanding that there are differences within the workflow here is important for you to be able to have success. Okay. Any other questions, Jeremy?
Yeah, we do actually have a couple in here. Jeremy's been answering away quite a few of them in the chat, but I can give you a few here live that Jeremy hasn't had a chance to get to. Okay. One is around on the Nautobot side. Are you able to show possibly the GraphQL query or kind of the under the hood, what's happening as far as the attributes versus config context as far as in Nautobot, how that's working? Wonderful.
Wonderful question. Yes, absolutely. So here within Nautobot, and this is one of my favorite features of Nautobot. When I discovered this, I don't know, I had to tell my wife because I was just so happy about this and she didn't care. But what I've discovered in Nautobot is that they give you the capability of actually staging repeatable GraphQL queries and then exposing that over an API by passing in a parameter. So in my case, I have a GraphQL query that looks something along these lines, right? So it's grabbing information out of Nautobot, like give me information about my device, its host name, its IP address, give me any tags, tell me what tenant this belongs to, tell me the platform, the operating system version, right? That's really important when you start pushing configuration changes, because if your operating system doesn't support a specific configuration object or the schema is a little bit different, you need to have some kind of mechanism to determine whether or not your configuration needs to be adjusted. So again, pulling additional metadata out of Nautobot is really important for our automation workflow. We can also look at firewall policies. I'm not going to spoil this. I'm going to leave Jeremy to talk about the firewall plugin and the SSOT. There's some real good information right in there. But again, additional context on like, what's my interface config, how's the site built, et cetera, et cetera. Now, the only thing I need to do is I need to pass in my device ID, which was the very first step in our Ansible playbook up here, was to determine, well, actually it was to do the sync, but it was to retrieve our firewall's UUID from Nautobot. So in my case, I think let's grab this firewall UUID. I'm going to come and grab this guy right here. And this is what I need to pass into the GraphQL parameter. Now I've left this as a parameter to pass rather than hard coding it, because now Ansible can use this GraphQL query and pass in any device and get the respective output. If I execute this, then this is the exact representation of what the configuration looks like. Some of this was pulled out of Nautobot data. Some of this was pulled from my group variables within the config context repo. So, and then all the other stuff came from the device specific YAML file. So it's this nice, it's like Voltron, right? It's pulling in different pieces to kind of assimilate this powerful being of data to present into our automation. So good stuff. Good question. I see some questions about Panorama. So Sam asks, is this workflow essentially replacing Panorama, or does this also work deploying Panorama device groups and templates versus directly to a firewall? Wonderful question. This workflow absolutely can work with Panorama, and actually we recommend going into Panorama for a couple of different reasons. First of all, as you mentioned, there's automation features within Panorama today around things like device groups, templates, variables, and built into Nautobot. And the absolute best workflow is to be able to consume some of the features that Panorama already exposes. The second benefit that we get if we go to Panorama is that we no longer have to worry about like the devices management IP, right? Because we know all API endpoints are now going to be talking to the Panorama IP address. So if you've got an inventory of maybe like 5 firewalls, that's not going to be tremendous of a savings. It's good, but it's not good, or it's not great. If you've got a fleet of 100 firewalls, finding each of those firewalls management IPs and getting all this data, as you can imagine, it can be pretty cumbersome. So having like a central point for the API to speak to, or Ansible to speak to, in this case, being Panorama, is absolutely the preferred way of doing this. Another benefit here with Palo Alto is that our Ansible collection, our Ansible modules, they will work against the firewall as well as Panorama itself. So you don't have to learn a new module. The only thing that's different in the execution is you would reference a device group or a template within the Ansible parameters. But other than that, if you're using Ansible today for all firewall provisioning and you want to migrate it to Panorama, you can take all of your hard work that you've already built and then just add in like a device group or parameter into your Ansible modules, and you're up and running. So good question. This does not replace Panorama, and it never will. Panorama does a config check as part of its push. Does this solution perform that check? Wonderful. So we can absolutely this is more about like the commit operation. There's a validation process that takes place. So there's validation that's happening in a couple of different layers. One, yes, this can absolutely incorporate that validation process into the workflow. And again, highly recommend it. But there's also kind of validation in the fact that since we're using the Ansible modules to build the configuration, there's validation built into those Ansible modules to make sure that we're passing the right parameters, that we're not calling something that doesn't exist. So there's validation that takes place in a couple of different places. Yes, the validation within PanOS or Panorama to make sure that at the end of the day, the constructed config is valid, but there's also validation just by consuming the Ansible modules as well. So really good point. Just for the commit, there should be some throttling and commit scenarios for large enterprises. So another good question. There is that commit operation that we're talking about can be time consuming in a couple of different ways, right? Depending on the amount of policy changes or the amount of configuration, as well as the size of your device groups, how many devices need to take place. These questions that you bring up are absolutely something that need to be determined internally within your team to see kind of what you all feel comfortable with, right? Is it one commit for everything, or do you want to break it up by device groups, or do you want to break it up by devices? There's a couple of different options to go around. It's ultimately comes back to what you feel comfortable with.
Hey, right. Calvin, just to make sure that we have enough time for Jeremy's section here, we're going to move on to that, and then we can go back to any questions if we have time at the end. So
wonderful.
Absolutely. Thank you for this great section. And yeah, now we'll pivot over to continue on here for Jeremy.
Awesome. Sounds good. Thank you so much. Great content. I love seeing the journey. I love seeing kind of talking through what things may look like and what we may be seeing on our current daily basis, and how these paradigms may be shifting, and how we may be seeing interactions with Ansible and Panorama and from a security policy perspective, and how Nautobot fits into the picture from a data enrichment perspective. I'm going to answer one last question live because I think I was typing it out like 4 times, but kind of around managing config contexts for devices. And is it just a local context, or is it global contexts that are applied across all devices? You get the best of both worlds. You can have absolutely a config context that is device specific, And you can have a level of inheritance similar to Ansible group vars that can be inherited from a site, a region, or other attributes or other related models to the device object itself. So yes, you can have your cake and eat it too. You can have some level of inheritance, and you can have levels of override, and you can have your local context itself. Awesome. So I am picking up and talking about the introduction of source of truth and how this kind of fits into the paradigm within Nautobot itself. So some of the questions that we were already seeing in the chat is kind of getting started. And is this replacing Panorama? Is there an easy way to onboard and get everything into Nautobot without having to go through and tediously clicking through the million different menu items or building a specific playbook just to scrape Panorama and then turn around and do API calls back into Nautobot? And this is something that, if you've ever tried to manage these disaggregated sources of truth into one coalesced source, it can get very, very cumbersome at times. And so what we have the ability to do is, by introducing and the scenario that we're in is where we especially in the beginning, where we're trying to sync into Nautobot, we're trying to have that representation. We create that one-way sync. But as soon as we create that one-way sync, we start getting out of date. And the minute we sync it, it can potentially be out of date. And someone could be going into Panorama or whatever upstream source of truth it might be and make a change. And then all of a sudden, now Nautobot is out of sync. And then now we're back to trying to sync back into Panorama. This kind of ebb and flow scenario, what this kind of evolves into the breakdown of the trustworthiness of data. How are we able to effectively enrich this data and be authoritative from that perspective, especially if we're leveraging Ansible or other solutions that are idempotent, that are enforcing a intended state from an upstream source of truth? We want to make sure that if we update that policy inside of Nautobot or inside of the config context, that policy is staying at least some level of healthy. And so that if someone else comes behind you and makes an update inside of Nautobot and that change gets pushed out, person A's change doesn't automatically get blown away. Another thing that we get with this paradigm within Nautobot is going to be the data collection and enrichment portion. And this is where we start getting into our SSOT and the ability to map policies to our IPAM objects. So kind of also taking a step back and understanding this additional data enrichment, that Panorama is not a DSIM tool and Panorama is not an IPAM tool. And so there's not this direct correlation or this direct relationship that you get natively within Panorama or any security policy tool. And you don't necessarily want to put a square peg in a round hole. If it's not a tool that's purposefully meant for managing those data domains and it's not the authoritative source, then having Panorama be the authoritative source, having an IPAM solution and it not be the authoritative source, we start getting into a scenario where we're at a source of lies. And this is something where Panorama does a phenomenal job from the policy management and the device group and how everything is managed at scale. And it's not an IPAM. It doesn't have IPAM. It doesn't have DSIM. And as we start looking into Nautobot and how we enrich that data and how we start bringing things together, we have the ability to tie the objects inside of a policy to IPAM objects. And those IPAM objects could be directly related to your DSIM objects. And so in this specific scenario, we could have all of our server infrastructure and all of the port communications, all the services that are running, all the expected items for communications in our application to be healthy, fully documented within Nautobot. And we can have the ability to have the very specific IP addresses tied to address objects that are then loaded into policies within Panorama and see this full circle, this full ecosystem of seeing all of the relationships and how everything kind of fits back together, and gives us additional visibility, additional traceability when it comes to potentially path communications and troubleshooting, and how that enriches the experience. And in this scenario, this is how we start talking about leveraging Nautobot as the nucleus of network automation, and how we're pulling in all these different data sets into one centralized source of truth, where we have our DSIM data of IPAM, config context, device level attributes, and then policies and object to device correlations, and how this then flows down into how the underlying users are interacting with the networking devices and interacting with the infrastructure as one common configuration management layer. And we're not having to have a different configuration management experience when it comes to route switch versus security versus ADC, how everything is one common configuration management profile or configuration management solution. And we see this exact evolution in how we have our DNS servers as objects inside of our policies that are then able to be correlated directly to an IPAM object that are then able to be traced directly to the actual server infrastructure inside of Nautobot, and see how this can all very easily and cleanly map together and not just be I have DNS servers or an IP address as an address object inside of our policies. And last, as soon as we start introducing the ability to have these disaggregated sources and how we're bringing them together to provide this very rich contextual portal in this single pane of glass, this single configuration management solution, we need to have the ability to find what are our deltas, what's the diff between what's being held inside of Nautobot versus what's currently inside of Panorama, and how do we effectively express that so network engineers can trust the automation. We can trust what's happening behind the curtain. We can understand that whenever we hit the big green go button, that it's actually going to do what I want it to do and not do some nefarious thing that I don't necessarily understand. And that's always been a struggle within network engineers jumping into net DevOps or network automation, is being able to trust that what's being pushed to the remote from an item potency perspective is exactly what I want it to be. And be able to see, okay, what are my actual CLI commands? What's my actual payload? What is it actually going to be doing so I can know and trust what's going to happen? And how can we leverage Nautobot and golden configuration with this whole ecosystem and framework to enrich that experience? Because we always just want to make sure that the engineer trusts the automation and is able to trust that what is actually going to happen is the expected behavior. And this is where we get to Firewalls as code with Nautobot SSOT. Terribly sorry about that. I think that someone is going a little crazy outside. She's a very interesting pupper. So as we start looking into how this kind of evolves and kind of correlates together, we have all of these underlying objects and these items that are inside of the Nautobot Firewall models plugin, and how they can be directly related to underlying objects inside of Panorama, and how each one of these items can be a one-for-one correlation. And we can use this to model out exactly what our policies and what everything may be inside of Nautobot, similar to how we are building and managing our network infrastructure. And then we introduce DiffSync with our single source of truth framework, or SSOT. And so from a very, very high level within DiffSync, you create this common data model. And to be able to get everything to work with this common data model, you create these adapters for each underlying technology. So on the left, we have Panorama, and we have our Panorama adapter that is able to extract, transform, and load the data from Panorama into this common data model, so that we can be able to see a same for same, side by side, what's the delta, what's the difference. And very similar on the Nautobot side, we pull the data out of the database, we transform it into this common layer to where we can perform that delta, we can perform the diff between Panorama and Nautobot. And this is pushed into the common data model, and then we are able to then push that back out into the target solution. So we can have the ability to then, using this common data model, to then push back out to either Panorama or to Nautobot. So in this scenario, we can have data coming in through Panorama into this common data model and then being pushed back out into Nautobot. And then on the flip side, data coming in through Nautobot to the common data model to where we're able to translate it and then push back out into Panorama. And where this is very, very powerful is the ability for you to easily and quickly onboard your full Panorama solution into the Nautobot firewall models and not have to worry about creating that separate playbook or going through and clicking a million times to generate every IP, generate every address object, every service, every policy or device group. And Golden Config comes into the scenario because as we are able to collect and transform each disaggregated data model into its one common model, we are then able to post this common model into Golden Configuration and to be able to see what is the delta, what is the difference. And so as an example here within our zone configuration, our common data model for our zones, we have a difference between our intended and our actual. Our actual delta is specifically, we have an additional interface on this specific firewall. And so giving the ability to showcase this is what the delta is, and this is what we're going to be remediating to try and demystify exactly what the issue is behind the scenes. And this is a native capability within Golden Configuration to be able to leverage structured data or CLI-based configurations to perform configuration compliance. Now, from the remediation portion, this is also where we get back into the scenario of the SSOT, the single source of truth framework, and the ability to have that continuous infinite loop of ingest, transform, load, and be able to take in the data from Nautobot, ETL it to our common data model, and then push it back out into Panorama, and how we can keep Panorama in a healthy and up-to-date state. All right, so we're not going to do questions just yet. So now we're going to jump into a awesome demo. And I'm going to be doing fingers crossed, everything is crossed to make sure demo gods are smiling down. So right now what I have is my local development instance of Nautobot. And if we take a quick look, I have a site of just Panorama staging. I've got just a simple Panorama demo device, which is just kind of showcasing the actual Panorama that I'm interacting with. I have some local plugins, local plugin models that are not open source at this time, but we are absolutely exploring what this is going to look like from an open source perspective. So we have our control plane system, which is our ability to model out our Panorama device. What are our port communications? What is our FQDN? How are we connecting to Panorama? And then we also have our virtual system. So if you're familiar with Palo Alto, this would be this is going to be a direct one-for-one mapping to vSys, which is going to be like a virtual partition or a logical partition inside of a firewall itself that you're then able to assign to specific device groups and have specific physical interfaces associated from the parent firewall that are unique to that specific vSys. And different policies can be applied on multiple different vSys on the same Palo Alto firewall. And lastly, we have which is going to be logical groups. Logical groups from this perspective is a one-for-one translation of our device groups inside of Panorama, and the ability to have a level of uniqueness and a level of inheritance when it comes to assigning policies and assigning devices to specific groupings. So as we get into what this looks like and how do we actually get the realization of value, we come into our Nautobot jobs. I'm just going to quickly minimize the Kupirka jobs and the Golden Configuration. And the first one we will focus on is the Panorama to Nautobot. And so in this Panorama to Nautobot job, it's going to be reaching out to the Panorama device. It's going to be scraping all the data from every device group, every policy, every address, every application, everything that is configured inside of the Panorama, and it's going to be translating that into that common data model. We are going to uncheck dry run because we want to actually implement and actually push this data into Nautobot. I'm going to select my specific Panorama device. This gives us the ability to have more than one Panorama instance that we could be working with. And then I'm going to leave compliance checked. And I'll be getting into compliance just a little bit in a moment, but we'll click run job. And as we're running, we'll start seeing our log messages coming back in of reaching out to the Panorama, starting to collect and cache our address groups, our address objects, our services, our applications, our firewalls, our policies, and how we continue to grab and collect data from our remote Panorama. And if we come back to our presentation and we go up, we are in this scenario right now where we are using the Panorama adapter of collecting data from the Panorama device and transforming it into this common data model. So right now, the actual job is in this scenario where it's gathering data from Panorama and pushing it into the common data model. If we come back, we'll see in just a moment that we then go into loading data from Nautobot. And as we start loading data from Nautobot, we are in this side of the scenario where we are grabbing data from the Nautobot ORM, transforming it into this common data model. And then now we're in our A/B diff scenario. And since we had selected Panorama to Nautobot, our next decision path is going to be sending the actual updated data or the expected state into Nautobot. And if we come back over here, we'll see, if I scroll down, that we created 69 items. There were no updates, no deletes, changes, or skips, mainly because these are items that didn't exist. This was a brand new clean instance, nothing configured inside of Nautobot. And if I take a look at my SSO sync details, we'll see every single specific object that will be syncing in and what is getting created. But if we take a step back and we think, oh, this isn't really user-friendly. This isn't giving me the warm fuzzies or understanding of what is actually getting pushed to the device or what my current state is. And so if we come back over into golden configuration and we click on configuration compliance, we'll see that we have our NTC demo Panorama device. And as we drill into it, we'll see every specific section around address object, address groups, policies, applications, services, and we're able to see exactly what this common data model looks like. And so you'll see that this is not a one-for-one for every single attribute that may live in Nautobot or may live in Panorama, but it's only the attributes that we care about to synchronize between the two systems. And we can see exactly what the current state is and how we are from a compliance perspective. Now let's go in and let's actually create a, and if we take a look before we do that, that we have our policy, and if we for our demo of our pre-rules, we have deny streaming as our last item in the policy, denying Netflix. We have our allow webinar app. And if we take a look at this in the security menu, go to policies, we go to demo pre and policy rules expanded. We'll see exactly this. We'll see exactly that we have our deny streaming, we have our allow webinar app, we have all of these items that are coming into the policy that were dynamically created from the SSOT plugin from Panorama. And we'll also see that we have the device created from Panorama automatically here. And because Panorama is not a DSIM tool, so we don't have a direct relationship to sites or regions or location, we're automatically creating the device inside of Nautobot as a staging status because we just onboarded. We don't know necessarily where it needs to go or what its current status is. Our role is staging, and everything is basically saying staging, 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 because these are attributes that are authoritative from Nautobot, and we can update inside of Nautobot, and we're not syncing those attributes because those attributes may not have a direct place to live inside of Panorama itself. But if we come back here, we see we have our policy, and if we want to, let's say, update the policy by adding a new policy rule, we can go to policy rules. We'll say allow users to Nautobot demo. This is going to be index number 9 because the first two are being automatically coming from a upstream shared policy. We'll specify our source zone. We're going to say that our source service objects and our source address objects, we're going to say any. that any source address or any source service is perfectly fine. The opinionated implementation from the Nautobot firewall models for this scenario is that if something is not specified, it's implied that it's in any relationship. In our destination service, we're going to say we want HTTPS, and destination address object, we will select, let's just for quick grins, we'll do 192.0.2.1.1. And we're going to say that we will allow this. We'll create, and now we'll go back to our policies and we'll assign this to our policy. And allow users to Nautobot demo, update, jobs, and now let's sync from Nautobot to Panorama. So if we hit play, we're going to say we are not doing a dry run. We are selecting our specific Panorama instance, and we are saying that we do want to run compliance. Now, do keep in mind that this is set that if you're running compliance and dry run is not set, it will rescrape the target adapter to validate that the intended state versus the target state is in the appropriate configuration state post push, so post sync. So to kind of deconstruct what I mean by that is we ETL the data, we extract the data from Panorama and Nautobot, we push it into our common data model, and then because Nautobot is the authoritative, is the source, we then take the delta, the diff, and we push it into Panorama. But we want to run compliance. We want to see that our change was executed successfully. So then we're going to rescrape the data from Panorama and perform the configuration compliance based off of that data that we just rescraped from Panorama and continue on. And so we can see as we scroll down that we created 2 objects and we updated 1 object. So if we take a look at our sync details, we should see that I have updated the policy rule names for the demo pre policy. We'll see that we've created a policy rule and created a service object. If we come over into Panorama and I just quickly update, we'll see that I now have allow users to Nautobot demo. We see our source destination zone, we see our HTTPS, we see our address objects are there, and now we have our expected configuration state inside of Panorama. I see that I do have a tiny little bug in there, the implementation details, which is all good. But now if we come back into go in the configuration and check our configuration compliance, I am expecting the policy rule to be failing. Because if we took a look here, I actually have 2 of the same exact IP address instead of 1. So it looks like I need a few more cups of spicy bean juice to be able to ensure that I don't leave anything fun in this in the weeds. But now if we filter to just the policy rules and see what the delta is, we can see exactly what this payload that's coming from the common data model and what is our intended and what is our expected and what specifically may be missing. So if I scroll down too far.
For those of you that may have to drop here due to us reaching the top of the hour, we will release the full recording out on YouTube. You can see that there. But yes, we are aware we're at the top of the hour.
Yep. Yeah, that is our fun demo and showcasing the flexibility and the power of integrating Panorama with Nautobot firewall models and how we can leverage our SSOT framework and golden configuration to have a single authoritative place to manage all of our network hardware in a same fashion. So route switch is the same as our security policies, as the same as our ADC devices, and not having these disaggregated solutions, and how we can use Nautobot to enrich these experiences. Let's see.
Jeremy and Calvin, thank you so much for the presentation today and being part of the panel. For all of our attendees, thank you for joining us. We're definitely looking forward to seeing you at the next one as we carry on and we do these regularly. Thanks, everyone. Have a great day.
Thank you.